Hello everyone. This question has been taken from Olympiad Pathfinder Chapter 1. Build up your understanding. Question number 36. The load A is being pulled with the help of two inextensible strings that pass over two fixed pulleys as shown in the figure. This figure is given. At an instant, velocities of the ends of the string being pulled are u1 and u2. And the angle between the strings connected to the load is theta. What is the speed of the load? So it is asking with what speed the load is moving when your ends of the threads, this and this end, is u moving down with the velocity u1 and here with u2. This pulley is fixed. String is inextensible. So let us say that A is moving with a speed v in this direction. We just assume. Okay. And this angle is alpha. So this angle will become theta minus alpha. This point is moving with velocity v, means A load will also be moving with this velocity in this direction, right? Because A is attached to this point. The load A is attached to this point. So if you take the component, see, v cos theta minus alpha, component of this point moving in, this is the resultant velocity of this points. Okay, so the component of this velocity in the direction of this should be equal to u, because your rope is inextensible. If it will not be the case, then the rope will break, right? Because rope is integral from here to here. It is one rope or one string. Sorry, it is given a string, so we should say string. So string is 1 and it is inextensible. So if this point which is on this rope as well will must move with velocity u1 in this direction. So the component of v in this direction will become v cos theta minus alpha is equal to u1, which we can write further. Cos theta into cos alpha minus sin theta into sin alpha u1. So this is your equation number 1. The same way, the component of v along this rope, along this string will be equal to v cos alpha, and that should be equal to u2 because the rope is inextensible. So this point is also attached to this rope. So with whatever velocity this rope is moving, each and every point of that rope should move with u2, right? So v cos alpha is equal to u2. So this is your second equation. So from 1 and 2, wherever v cos alpha is there, we will replace with u2, right? So your v cos theta into cos alpha minus sin theta into sin alpha is equal to u1, right? So cos theta into v cos alpha minus sin theta into v sin alpha is equal to u1. So v cos alpha you can replace with u2. So this has become u2 cos theta minus sin theta. Now sin alpha from here you can write, or you just write just to be very clear. Okay, this has become your equation 3. Here it is sin alpha. Cos alpha we know, so we can deduct sin alpha from here, so from equation 2. Cos alpha is equal to u2 by v. So cos square alpha will become u2 square by v square. Cos square alpha is 1 minus sin square alpha. So 1 minus sin square alpha u2 square by v square. So sin square alpha will become 1 minus means v square minus u2 square divided by v square, right? Hence sin alpha will v square minus u2 square by v square under root, which you can write v square minus u square square root divided by v. So this is equation 4. So from 3 and 4, just write down u2 cos theta minus sin theta into v sin alpha you replace by this is equal to u1. V and v cancel out. So your this equation has become u2 cos theta minus u1 sin theta v square minus u square. Sorry, u2 square. So therefore u2 cos theta minus u1 whole square v sin square theta v square minus u2 square So v square minus u2 square has become u2 cos theta minus u1 by sin theta whole square. So v square is equal to your u2 square plus, if we just cos square theta plus u1 square to u1 u2 cos theta and u2 square, and this one will become sin square theta. Sorry, this one here you can write sin square theta because u2 you have brought this side and did like this. So u2 square sin square theta, u2 square cos square theta, u2 square common, so sin square theta plus cos square theta will become 1. So this is your u2 square plus u1 square minus 2 u1 u2 cos theta divided by sin square theta. Hence v will be u1 square plus u2 square minus 2 u1 u2 cos theta square root by sin theta. So this will be your answer because v is the speed of the block A which we have taken here. So hopefully the concept behind solving it is clear. Basically this part is very important, that inextensible what is written is inextensible. So when you are pulling the rope, each and every part of the rope, every point of the rope should move in this direction with u1 at that instant. Same way for this rope also. So means A will move with u1 this side, u2 also this side, and resultant speed we have taken it as v, that load this point A where both the ropes are connecting is moving with a velocity v in this direction. So this is the resultant. So resultant one component along this rope will be equal to u1, component along this rope will be equal to u2 because this point is attached to both ropes. And this is the way you calculated it. In case any issue in understanding at any point, please write in the comment box. I'll clarify it further. Thank you.